Hi, in this video you'll learn about the hypergeometric random variable. The particular example we're going to look at is selecting parts from two suppliers. Here's the problem setup. A batch of parts contain 100 that come from a local supplier and another 200 that come from an out-of-state supplier. So we have in total 300 parts, and this is going to be a hypergeometric, and we let capital N be the total number of parts or the total number of objects. Okay, we're going to select 4 parts randomly and without replacement. So again, in hypergeometric language, little n is the sample size. We're selecting 4. And there's a couple important words here. We're selecting those parts randomly. But more importantly, the words without replacement is what makes this a hypergeometric example and not a binomial. So when we select a part without replacement, what that means is, let's say we select our first part from the local supplier. We don't look at it and say it's from the local supplier and then put it back in the batch of total parts again. Once it's out, which is then going to decrease our sample size from 100 down to 99 parts. So that without replacement then makes that probability of success, let's say choosing a part from the local supplier, it changes that probability as the sample size changes. And that's why this is not going to be a binomial random variable. Okay, so what are we looking to compute? What's the probability that, again, we draw 4 out of 300, and those 300 are broken into 2 classifications. What's the probability that they're coming from the local supplier? So again, I'll go ahead and give you the rest of the hypergeometric language. Capital N is 300. Capital K is the number of successes that are available. And here, out of the batch of 300 parts, we're considering 100 of them as successes. And the other N minus K parts would be the ones from the out-of-state supplier. So this is 200. Okay, so we have all of our constants now for the hypergeometric. And I guess I just want to stress that point one more time. I mean, this would be a binomial if you weren't keeping the parts out and not replacing them. Because if you think about it this way, we have 300 total parts, so we could say, well, a third of them are from local supplier and 2/3 of them are from the out-of-state supplier. But you can see now that that 1/3 isn't staying constant. I mean, again, when you take out a part from the local supplier, the 1/3 is going to change. So I don't have that constant probability that I need in a binomial. Okay, so to solve this problem, I think most importantly, we have to start and have a random variable x. So let's let x be the number of parts from the local supplier. Okay, and we know how many there are. There's 100 of them. Okay, so let's go ahead and set up the hypergeometric probability mass function. That is f of x. Okay, so this is a pretty classic one. I mean, I have 300 total parts, and they're broken into 2 categories. So on the bottom, all I want to know is the number of ways to select 4 parts out of 300. I'm doing it without replacement, and order doesn't matter. So this is a classic combination, 300 choose 4. And on top, I'm breaking into the 2 categories. 100 of them are from the local supplier, and 200 of them are out of state. Now we let x be the number of parts from the local supplier. So I want to know, of the 4 I choose, what's the probability of x of them coming from the local? And if you choose 4 parts, then the other 4 minus x come from the out-of-state supplier. My support is x starts at, so again, this is the number of parts from the local supplier, could be none. It's possible that none of them do, or one of them all the way up to 4. And notice I don't have my support go up to 100 because I'm only selecting 4 parts, so it's going up to little n here. So let's see what we are trying to find. We are trying to find the probability that all 4 of the parts are from the local supplier. So I'm trying to find probability x is equal to 4, which in turn is just f of 4. Okay, so let's go ahead and put 4 into our hypergeometric. That's 100 choose 4, 200 choose 0, divided by 300, choose 4. Okay, and 200, choose 0. This is just going to be 1. And so let's write out what the others are in terms of factorials. On the top we have 100 factorial divided by 96 factorial times 4 factorial. And on the bottom we have 300 factorial divided by 296 factorial times 4 factorial. And I went ahead and multiplied these out. In the top, we get 3921225, and in the bottom even a bigger number, 330791175. And so when I divide this, I get approximately 0.01185. So again, this is the probability that all 4 parts are from the local supplier. And again, they only have 100 of the 200 parts, so I'm not too surprised that this is a small probability. So recapping, what we had here was a hypergeometric random variable. We set it up in terms of a hypergeometric probability mass function. 300 was our population size, and there were 2 categories. So notice that 100 and 200 add up to 300. We're selecting 4 parts. X of them are from the local, and the rest were from the out of state. And our support goes from 0 to 4. To find any probability then, f of 3, f of 2, we're just going to stick that value into our mass function. So, and then we got a final probability. And again, I'm going to stress one more time, what makes this hypergeometric compared to binomial is that we're sampling without replacement. Classic hypergeometric. Okay, so we will talk again soon, and I hope you feel good about the hypergeometric now.